Hello everyone, welcome to today's movie. In today's movie we're going to take a time series data set and in this particular movie we're going to look at modelling the level, modelling the trend and also including seasonality, and we'll be using Holt-Winters method and we'll be using the multiplication version of that method. In this movie we'll be using SPSS. In a previous movie we used Excel, so if we just remind ourselves about the Excel solution, and also that this was about a data series that was measuring over a period of time from 2015 quarter 1, quarter 2, quarter 3, quarter 4, etc. what the CO2 emissions are in parts per million measured at an observatory in Hawaii from 2015 quarter 1 to 2020 quarter 2. And what we did was we fitted, if I go to the other screen, we fitted Holt-Winters multiplication model to this data set. So there's the model fit to the data, and these are the forecasts for the future for 2020 quarter 3, 2020 quarter 4, 2021 quarter 1 and 2021 quarter 2, etc. That was the initial solution where we had alpha, beta and gamma fixed at 0.5. Then we used a solver to minimize the mean square error for alpha, beta and gamma, and we came up with these solutions. So we can see that in 2020 quarter 1 the model predicted 412.5 parts per million. In quarter 2 2020 it was 412.9688. Quarter 3 in 2021 quarter 1 it was 416.66, and in 2021 quarter 2 it was 419.17. Now we know that using Excel it's quite a lengthy process to set up this. We also know, if I go back to the original tab, that the initial values are there, are given by those equations. Please note, as we said in the previous movie, that other books and also other software packages like SPSS, like Minitab, etc. will probably have different starting procedures values than is given there. So the results will always be slightly different. Okay, so let's go to SPSS and look at SPSS solutions. So I've got the data file open there. So you'll see there's my original data and there's the time points that we want to forecast for. Okay, so what we'll do first is, because this is time series data, what we need to do is set the date time. So click on data and then define date and time. And remember, hours are in years and quarters, so we scroll to the top, years and quarters. We started at 2015 and it was quarter 1. So if we click OK, and then if you go back to the data file in SPSS, you will see that the year and the quarter, the date therefore have been input. So what we need to do now is we need to fit this Holt-Winters exponential smoothing model to the data. Okay, so all we do is we click on Analyze, we click on Forecasting, and then we click on Create Models. Now once we've done that, we need to tell it what the model is. But first, we'll just transfer series to the dependent variables box. Then the method is exponential smoothing. Then we need to tell it which one we want. So click on Criteria. Now we want a model that deals with seasonality, and we want Winters multiplicative method. Okay, so choose that, click on Continue. Now we need to tell it what sort of statistics, what sort of plots to create for us. So let's click on Statistics. I'll switch off stationary R-square, I'll put root mean square, and I'll display the forecasts as well. Then once we've done that, if we click on Plots, then we can tell it what plots we want. So I can fit the values to the original data set, and it will give you your prediction fit forecasts as well. Now, please note that in Excel, you could actually create prediction intervals, etc. for the forecasts and the fit values. And you can do that quite easily in SPSS by clicking on those two boxes there. Now, if I click on Save, and then what I want to do is I want the predicted values created as a column. And I may as well have the lower and upper confidence intervals as well. And then if I click on Options, then I can tell it that I want the the first case after estimation to be 2021 quarter 2. Okay, because there it is, 2021 quarter 2. Okay, and then if I now click on OK, then you should find that the model parameters and the model type information is all put into the output file, as you can see here. And there's your graph model fit as well, and see how well the actual model fits the actual original data series. But in the SPSS data file, you will see that you've got your fit data and you've got your two confidence, the lower and upper confidence interval for each predicted value there. Okay, so if we now do a screenshot, so I just do a screenshot there. All I want is that information there. Give me a couple of seconds and I'll just copy this over to Excel. Okay, so this is my optimized solution there. So I'll paste it in there. And if I just drag that across there, make it a little bit bigger so you can see a bit more clearly. 1 second. Okay, so you can see that for the first fit, it was 400.6. Can you see there? Look, you get exactly the same answer, 400.6. The next one's 403.3467, 403.34. Well, it's just slightly out by in the second decimal place. Now, if you look at the forecast for these time points which don't have series values, then the first one was 412.53, 412.52. Oh, sorry, 412.52. Oh, no, 412.51, apologies. And there it's 412.52. The next one's 412.97, 412.93. So it's just slightly out in the second decimal place. And the last one is 419.18, 419.22. So it's just slightly out, that's all. But that's probably because SPSS uses different initial starting values, etc. Okay, so you can see that you get comparable, if not agreeable solutions between Excel and SPSS. Okay, so that's the end for now. Keep well, everyone. Bye.